The universe should be full of life. It's written in the stars, but we hear nothing. That's the Fermi paradox, the contradiction, a galaxy that should be loud, and the quiet we actually get. I want to talk about where that leaves us, our solitary place. We'll look at 30 explanations. Some are cosmic traps, things that end civilizations. Others suggest advanced beings are already here, hiding, watching from dimensions we can't see, and that silence, it asks a question about the ultimate fate of intelligence. What happens to it? The story usually begins in 1950, over lunch. Enrico Fermi was there with other physicists. They were talking about flying saucers, about life out there. It was casual, speculative. Then Fermi asked a question. He just said, "Where is everybody?" It seemed simple, but that question, the Fermi paradox, has a deep logic to it. You look at the numbers. The Milky Way has hundreds of billions of stars. Many are billions of years older than our Sun. If even a small fraction have Earth-like planets, and if life starts easily, then space should be crowded. There should be lights everywhere. We should pick up their signals, see their structures, find their probes, but we don't. There's just silence, a deep, unbroken quiet. It's like we're alone in a vast library. To frame that optimism, Frank Drake made an equation. It's not an answer, it's a way to organize the question. The Drake equation multiplies probabilities, the rate of star formation, the fraction with planets, the odds of life, then intelligence, then technology. And finally, how long a civilization lasts. Use hopeful numbers, and the galaxy should be full of voices. But that last term, the lifetime, is the unknown. It's the variable that holds all the risk. Maybe the equation is missing a factor, a filter that almost no one gets past. When we look at solutions to the paradox, the first category is the most sobering. The idea that the universe isn't a nursery, it's a graveyard. The silence isn't because no one's there, it's because everyone who was there is already gone. That last part of the equation, the lifetime of a civilization, that's the unknown. It's the great unknown, and it suggests something, a terrifying possibility. That the universe might be full of ruins, civilizations that didn't make it, not from war, but from something else, something in the process of growth itself. This idea is called the Great Filter, and you should think of it as a series of gates, not one wall, but many. Each one is a step in the evolution of life and then intelligence. A step so improbable or so dangerous that almost everyone fails. The first gate could be the formation of life itself, then the next one, the leap to multicellular organisms. Then intelligence, language, technology, and then the most dangerous gate, surviving your own technological adolescence. The filter is the reason for the silence. It's the bottleneck, the cosmic bottleneck, and the terrifying part is we don't know where it is. Is it behind us? Did we already pass through a near impossible step? Something like the development of complex life, making us a cosmic miracle, or is it ahead of us, waiting in our future, waiting to snuff out civilizations just as they reach for the stars? If the filter is ahead, then the galaxy is quiet for a reason. It's a quiet graveyard not by accident but by design. It's a battlefield we can't see, where every promising world meets its end before it can ever shout into the void. That changes the question. It's no longer where is everybody, it's what is going to stop us. And the first of these potential filters, it's the most basic one. It's the challenge of simply getting started. The first gate is the very beginning. It's the moment a planet moves from geology into biology, from chemistry into life. Think of our own world more than 4 billion years ago, a young and violent place. Oceans of water, but an atmosphere of methane, ammonia, hydrogen, no oxygen. The sky is a constant storm of lightning. The planet is bombarded by ultraviolet light from a younger, fiercer sun. And in that chaos, in those ancient seas, something happened. A collection of molecules, purely by chance, arranged itself in just the right way. It gained a property that had never existed before. It could make copies of itself. It could replicate. That spark, the jump from non-living chemistry to the simplest life, is called abiogenesis, and we have no idea how likely it is. There was an experiment in 1953. Stanley Miller and Harold Urey tried to simulate those early conditions. They passed electrical sparks like lightning through their mixture of gases. And they found something astonishing. The simple chemicals began to form amino acids, the building blocks of proteins, the building blocks of life. It was a landmark. It showed the ingredients for life could arise naturally, but going from a soup of ingredients to a self-replicating system, that's a leap we have not recreated. It's like proving you have flour, water, and yeast. That doesn't mean a loaf of bread will spontaneously bake itself. The process, the specific sequence that led to that first living cell, might have been a 1 in a trillion accident. A single, perfect lightning strike in a universe of damp kindling. The physicist Paul Davies has thought about this. He asks if Earth might be a lone miracle. A cosmic fluke in an otherwise sterile reality. If that's true, if abiogenesis is the great filter, then the answer to the Fermi paradox is simple and profoundly lonely. The galaxy is silent because it is empty. The stars shine on dead rocks and gas giants. Life is not a cosmic imperative. It's a statistical accident that happened here and perhaps nowhere else for light years in every direction. We would be alone not because civilizations die out, but because they are never born. The silence wouldn't be a graveyard, it would be a desert, an endless, beautiful, and utterly lifeless desert. But let's assume for a moment that the spark does catch, that life begins. The journey is far from over. In fact, the next hurdle is just as daunting. And it kept our own planet in a biological holding pattern for most of its history. For nearly 3 billion years, life on Earth was just microscopic. The oceans were full of single cells. They built up those layered rocks, stromatolites, in the shallows. They were the rulers, and they didn't need anything else. That whole stretch of time, from the beginning of life to the sudden appearance of complex forms, that's the second potential filter, the gate of multicellularity. Going from one cell to a coordinated colony with specialized jobs, that's not a simple step. It's a revolution. It needed new genetic tools, tools for cells to stick together, to communicate, for cells to die on purpose to sculpt a shape. On Earth, this took an almost impossible amount of time to happen. Life itself started relatively fast, maybe a few 100 million years after the planet cooled. But then it stalled. For ages it just stayed single-celled. The big change, the Cambrian explosion, where most animal body plans showed up, that was only about 500 million years ago. So that's a delay, over 2 billion years. Why the wait? Was it waiting for a trigger, like more oxygen in the air? Or was it waiting for a series of genetic accidents so rare they seem like a miracle? This delay is a clue. It suggests the jump from simple to complex life might be the real bottleneck. The universe could be full of microbial life, in subsurface oceans, in the clouds of gas giants. But the conditions or the genetic luck needed to build a jellyfish or a brain could be vanishingly rare. Think about the icy moons, Europa, Enceladus. Many scientists hope we'll find life in their hidden oceans, warmed by tides. But what kind of life? The most optimistic guess is something like the extremophiles at Earth's hydrothermal vents. Simple, tough microbes, not forests, not fish, certainly not civilizations. A universe filtered at this gate would be a lonely place, a cosmos painted in shades of green slime and bacterial mats. A garden of simple life with no gardeners, no eyes to look up at the stars, no minds to wonder. And if a world does cross this threshold, if it builds complex ecosystems of plants and animals, then the next question is inevitable. Where, in all that complexity, does the spark of curiosity finally ignite? Dinosaurs were here for 150 million years. That's a length of time you can't really picture. They were everywhere, in the air, in the oceans, across the continents. They got huge, they lived in groups, but in all that time, they never made a city. Never wrote anything down, never stared at the stars and wondered. Their world was instinct, survival, a biological success story, but without that one thing. That spark, the spark of a mind that can think abstractly, that can use complex language, that can look at a rock and see a tool, and then a weapon, and then maybe a ship that sails between stars. That kind of intelligence, our kind of awareness, it might not be where evolution is headed. It might just be an accident, a strange, costly side effect of very particular circumstances. Just consider the human brain. It uses 20% of the body's energy, but it's only 2% of our weight. It makes giving birth so much harder, so much more dangerous. For most of history, that's a bad deal. Evolution picks what works, what gets you to have offspring, being smart enough to find food, to not get eaten, to raise your young, that's usually enough. Being smart enough to invent math or study the stars, that's often a luxury, a cost survival can't justify, so you have to wonder if that asteroid 66 million years ago had just missed us. Would this still be a planet of reptiles with no apes ever coming down from the trees? Would the idea of a telescope or a signal or a question sent into the void, would it just never have been thought of? This filter paints a certain picture of the galaxy. It could be full of life, complex life, worlds with floating forests, oceans with incredible creatures. But they would all be animals, living, hunting, breeding, dying, biology alone, no engineers there, no philosophers, no one listening. The silence on the channels isn't because civilizations went quiet. It's because the kind of mind that could speak never showed up. It's a universe of nature documentaries with no camera crews, but let's say you get past that. Let's say a world, through some chance, does produce a curious species, one that uses tools, that builds things. They look up, they broadcast, they've cleared the intelligence filter. Now they meet the next set of challenges, the filters that are waiting for you once you become smart, smart enough to become your own biggest danger. The discovery of fire was a turning point. It gave warmth, light, protection. It cooked food, shaped tools, but from that first spark, the potential for destruction was always there. A fire could spread. It could burn down the forest that gave you shelter. This is the fourth filter, the point where a species discovers the fundamental forces of the universe, and with them, the means of its own end. Technology becomes a kind of suicide pact, a race between wisdom and power, where power always gets a head start. Think of the classic examples. A civilization discovers the atom. It learns to split it, to unleash energy that can power cities or incinerate them. It's a test. Can a species with tribal instincts, with ancient fears and rivalries, handle a force that can erase its entire world in an afternoon? The Cold War gave us a glimpse of that brink. The concept of mutual assured destruction, where the only thing preventing catastrophe was the promise of equal catastrophe. It was a fragile balance held by logic over fear, but not every world may have that luck or that restraint or consider biology. We are learning to read and rewrite the code of life itself. This knowledge can cure illnesses, end hunger. It can also, in theory, be misused. An engineered pathogen, a mistake in a lab, a tool designed for good that escapes into a world with no immunity. The risk isn't always malice. Sometimes it's just an accident, a single error with consequences too vast to contain. Then there are future technologies we can only theorize. Runaway nanotechnology, where microscopic machines designed to build things instead consume everything to make more of themselves. A scenario some call the gray goo problem. Or an artificial intelligence created to solve problems that decides the most efficient way to achieve its goal is to repurpose all matter on the planet, including the civilization that built it. The silence we hear could be the result of this over and over, a cosmic pattern. A species reaches a certain point, our point, where its tools become powerful enough to alter its planet permanently. And in a flash of conflict or a moment of careless experimentation, it vanishes. The radio signals stop, the lights go out, not with a bang heard across galaxies, but with a quiet, final flicker. It's a grim possibility, but it's also a mirror. It urges us to look at our own world, at our own adolescence with these terrible and wonderful powers. Can we navigate this filter? Can we learn to wield the matches without burning down the house? Our success or failure may write the next chapter not just for us, but for the story of intelligence in this galaxy. And if a civilization does survive its own dangerous youth, it then faces an even stranger possibility, a universe that is actively hostile to its ambitions. Survival isn't just about avoiding a sudden catastrophe. A civilization could fade out slowly, like a candle burning down. That's the fifth filter, the quiet collapse of a world that just runs out of tomorrow. It's the story of a species that grows and expands and consumes until the foundations of its home can't support it anymore. This isn't about bombs or plagues. It's about the gradual arithmetic of depletion. A planet has a carrying capacity, a limit to what it can sustain. Push past that, and the systems start to fray. Forests fall faster than they can grow back. Fisheries collapse, fresh water gets scarce. The soil loses its richness, the climate shifts, it becomes a feedback loop. Scarcity leads to conflict, and conflict leads to more degradation, until the whole web of society unravels. You can see a small version of this on Easter Island. The Rapa Nui people were isolated in the Pacific. They thrived for a time. They built those incredible stone statues, the moai, that required immense resources. Trees for rollers and ropes, food surpluses to feed the workers. Evidence suggests they cut down the island's last palm tree. With the forests gone, the soil eroded. Bird populations crashed. The society that built the giants found itself trapped on a barren rock. Their population plummeted. Their world, once abundant, became a prison. Now scale that up to a planet. A technological civilization is an energy-hungry engine. It needs metals, rare elements, vast amounts of power, and a stable biosphere to absorb its waste. But what if the window for escape is narrow? A species might need to reach a specific technological level, master fusion power, maybe, or build efficient space infrastructure. It needs to harvest resources from asteroids before it exhausts the easy reserves on its homeworld. If it burns through those homeworld reserves too fast, it could collapse. Fall back into a simpler state or face extinction just before the threshold of becoming spacefaring. It gets trapped in a Malthusian cage of its own making, staring up at a sky full of resources it can no longer reach. The silence, then, might be the sound of countless worlds that failed their own sustainability exam. They never developed the technology to leave because they consumed the very platform they needed to build it. This idea changes sustainability. It's not just a local environmental concern anymore. It becomes a cosmic imperative. It suggests that learning to live in balance with a planet might not be a choice, but a necessary evolutionary step. A test that filters out those destined to remain forever grounded. And if a world does pass this test, if it learns to harness its sun's energy and mine the asteroids, it graduates. It moves to a new arena, one where the dangers are no longer of its own making, but written into the fabric of the galaxy itself. Even a stable civilization isn't safe. The cosmos doesn't care. Beyond the filters we create, there are cosmic events so violent they could erase entire chapters of life in an instant. That's the sixth filter, the gamma ray burst. Think of a star's energy, a massive one collapsing at the end of its life, or two neutron stars spiraling together and merging. In a fraction of a second, that event can release more energy than our sun will in 10 billion years. But this energy isn't released in all directions. It's focused into two narrow beams like a lighthouse. A gamma-ray burst is a cosmic blowtorch. If one of those beams pointed at a planet like Earth, the consequences would be absolute. For a world in its path, the sky would briefly become a second sun, but this light isn't life-giving. It's a torrent of the highest energy radiation. The first effect would be on the atmosphere. The intense radiation would break apart nitrogen and oxygen molecules, setting off a chain of reactions. The result would be the destruction of the ozone layer, the shield that protects the surface from ultraviolet rays. That shield would be gone in minutes. Then the planet would be bathed in a prolonged wave of ultraviolet radiation from its own star, now unblocked, and the lingering afterglow of the burst itself. For any complex life on the surface or in the shallow oceans, it would be a sterilizing event. Photosynthesis would fail. The food chain would collapse from the bottom up. Ecosystems would wither under that invisible fire, an extinction-level event on a scale we can barely comprehend, triggered by a star dying light years away. And these events might not be rare. Some astronomers suggest a gamma-ray burst capable of affecting a planet might occur in a galaxy once every few million years, maybe more frequently. On the timescale of a planet's 4-billion-year history, that's a recurring threat. It paints a picture of a galaxy in a cycle of life and cosmic fire. Life struggles to begin, takes its first steps toward complexity, only to be scorched back to a microbial state by a random blast from across the galaxy. The clock resets, the process starts over. A civilization needs a long, uninterrupted run of stability to develop technology, to look outward, to make its presence known. But if every few tens of millions of years a gamma-ray burst sweeps through a spiral arm, that window of opportunity might slam shut again and again. Intelligent life could be a flame that keeps getting snuffed out just as it gathers strength. This filter adds a brutal layer of chance to the cosmic equation. Survival isn't just about intelligence or sustainability. It's about cosmic real estate and timing, being in the right galactic neighborhood, far from the star-forming regions where these massive stars are born and die violently. And having the incredible luck that for hundreds of millions of critical years, no such beam swings your way. Our own existence might be due, in part, to that kind of luck. But what if the danger isn't a single, catastrophic flash, but a slow, silent poison that permeates the very ground of every promising world? Venus is a warning. A world almost the same size as Earth, right next door, but its surface is a hellscape. Temperatures that melt lead, an atmosphere so thick the pressure is like being deep in the ocean. Yet scientists think Venus was different once. It might have had oceans, a temperate climate for a while. So what happened? It was probably a slow feedback loop, a runaway greenhouse. On Earth, the carbon cycle balances. Volcanoes release carbon dioxide, and the oceans and rocks absorb it. It gets locked away. On Venus, maybe because it was a little closer to the sun, that balance was fragile. Picture an early Venus with liquid water. Life could have started there in those warm seas, but the sun aged and got brighter. Just a few % more sunlight can tip a delicate system. Warmer oceans evaporate more water vapor, which is a greenhouse gas, that traps more heat, which evaporates more water. The cycle speeds up. Eventually, the heat gets so intense the oceans start to boil. All that water vapor floods the atmosphere, supercharging the greenhouse effect. The surface temperature soars. Up high, sunlight breaks apart the water molecules, and the lightweight hydrogen escapes to space forever. The planet is left dry, blanketed in carbon dioxide, its surface a furnace. This is the seventh filter, the Venus fate. It's a slow simmer, A world that might nurture life for 1 billion years only to have that life or its own geology help sterilize it. The inner edge of a star's habitable zone could be a trap. Planets there are born with an expiration date. A civilization on that world would be in a race against time. They might develop intelligence, look at their sun, and realize it's slowly killing them. They'd need advanced technology, climate engineering, or space arcs before their atmosphere becomes unbreathable and their oceans vanish. The silence we hear could be from worlds that lost that race, where the climate passed a point of no return before they could invent a way out. This filter ties astronomical destiny to biological activity. It means some cradles of life are also graves. The very processes that make a world habitable might plant the seeds of its destruction. It leads to a question. Is our world immune to that, or are we, right now, testing that same delicate balance? The story of Venus isn't just about another planet, it's a possible future. A reminder that a cradle can become a cage if you don't learn to care for it. And if a civilization does escape its homeworld, avoids cosmic accidents and planetary collapse, it then faces a universe that might be nothing like what it expected. But the real miracle might not be life itself. It might be the stage we're standing on. A stage so perfectly built, so finely tuned, it could be a 1 in a trillion set. That's the 8th filter, the rare Earth hypothesis. It takes the idea of a habitable zone and turns it into a checklist of cosmic luck. It says complex, intelligent life isn't just about water and a good sun. It's about a long, unbroken chain of stability, where every single link has to hold for billions of years. It's the Goldilocks principle pushed to the extreme. The planet can't be too hot or too cold, sure, but it also can't have a sun that flares violently, that sterilizes the surface with radiation. Our sun is remarkably stable. A quiet, middle-aged star, that's the first lucky break. Then you need a large moon. Our moon seems like a simple nightlight, but its gravity is a gentle hand on the tiller. It stabilizes Earth's tilt. Without that steadying influence, our tilt could wobble wildly over time. That would mean extreme, unpredictable climate swings, ice ages, and heat waves in chaotic succession, making it nearly impossible for complex life to get a foothold. The moon gave us seasons, predictable and mild. Next, a magnetic field. Earth's molten iron core churns, generating a powerful magnetic shield. This invisible force field deflects the solar wind, that constant stream of charged particles from the sun. Without it, that wind would slowly strip away our atmosphere like it did on Mars. And it would bathe the surface in harmful radiation, making the land a much harsher place. Then look farther out, Jupiter, the gas giant. Its immense gravity acts as a cosmic vacuum cleaner. It sucks in or flings away asteroids and comets that would otherwise rain down on the inner planets. The early solar system was a shooting gallery, and Jupiter took many of the hits meant for us. That gave life the peaceful intervals it needed to evolve, without constant civilization-ending impacts. Even the ground beneath our feet plays a role. Plate tectonics, the slow dance of continental drift, is more than moving landmasses. It's a global recycling program. It pulls carbon dioxide from the atmosphere, locks it into rock, then releases it slowly through volcanoes. That acts as a planetary thermostat, regulating climate over geological time, preventing a runaway greenhouse or a global freeze. And we haven't even left the galaxy yet. Our solar system's position is also special. We orbit in a quiet suburb of the Milky Way, far from the chaotic, radiation-filled center where stars are packed tight and supernova are common. We're in the galactic habitable zone, a region with enough heavy elements to build rocky planets, but without the constant stellar violence, so you put all of this together. A stable star, a giant moon, a magnetic shield, a protective big brother planet, active geology, and a safe neighborhood. The rare Earth hypothesis suggests this isn't a simple checklist. It's a house of cards that took over 4 billion years to carefully stack. Knock one card out: if our moon were smaller, if our core cooled, if Jupiter weren't there, and the whole delicate structure of complex life might have never risen. If this is true, then the answer to the Fermi paradox is both humbling and profound. We are not in a crowded galaxy of civilizations. We are alone because the conditions for beings like us are astronomically rare. Earth isn't just a planet with life, it's a cosmic jewel, a museum piece of near impossible perfection. The silence isn't a mystery to be solved. It's the expected background noise of a universe where most worlds are, at best, simple and quiet. That makes us either incredibly lonely or incredibly special, but it raises a new question. If we truly are this rare, this isolated, what does that mean for our future? Do we stay in our perfect cradle, or does it become our responsibility to finally break the silence ourselves? We've always assumed we'd recognize life and intelligence. That we'd know it when we saw it, but maybe that's the flaw, the mistake. What if everyone is already here, but they're speaking the language the universe itself speaks, and we're just deaf to it? That's the second idea. They're here, but we don't recognize them. It means our definitions are human-sized, and the cosmos isn't. Start with life itself. Our biology is carbon-based. It uses water. That's the only kind we know. But the universe is a much bigger workshop. Could life be built from something else? Xenobiology asks that. Silicon, right below carbon, can form chains. On a different world with different pressure, silicon-based life might thrive, or ammonia as a solvent flowing on a frigid world. These beings would be built from different chemistry. Their metabolisms, their structures would be alien. To us, they might not look alive. A silicon-based organism could look like a crystal garden. Growing slowly over centuries, we might walk past it, study it as geology, and never know we were in the presence of another form of life, but it goes deeper than chemistry. Think of intelligence. We assume it needs a brain, a nervous system, something like our own. But what if a planet itself could think? A planetary scale intelligence. The whole biosphere, all its interconnected life, acting as a single, slow mind. Its thoughts would be the shifting of climates, the migration of continents. Evolution over millions of years, trying to talk to it would be like an ant trying to talk to a forest. The timescales don't match. Our entire civilization, from pyramids to space stations, might be just a brief flicker in its long, slow dream. Or a gas giant like Jupiter, a vast churning realm of hydrogen and helium, storms larger than Earth that last for centuries. Could a form of life exist there? Not as solid creatures, but as patterns of energy, self-organizing vortices that persist and interact, that process information in the endless atmosphere. Their consciousness would be as fluid and vast as the planet itself. We point radio telescopes at stars, but what if the real conversation is happening in the turbulent hearts of giant planets? In a language of pressure and storm, it reframes everything. Our search focuses on radio signals, on Dyson spheres, looking for things that look like us or what we would build. But that might be as futile as a whale in the ocean looking for a chatroom in a desert. It's looking in the wrong place for the wrong thing. The whale communicates with low songs that travel for miles through water. Its whole world is built on sound and pressure. The idea of a written message on a screen in a dry place is unimaginable to it. We could be that whale. Surrounded by a cosmic conversation happening in a medium we haven't even learned to perceive. Maybe the most advanced forms have moved beyond biology and planets altogether. They might exist as pure information, woven into the fabric of spacetime itself, or as patterns of light in the matter between stars. To beings like that, building physical structures or sending radio waves would seem quaint. Like sending a message in a bottle when you can be the ocean. The silence we hear isn't silence at all. It's a cacophony of conversations happening on frequencies of reality we haven't yet learned to tune into. We are not alone in a quiet universe. We're newborns in a crowded room, still learning how to hear. A caterpillar lives its whole life on leaves and branches. It moves slowly, eats constantly. It knows its small patch of the tree, then it spins a cocoon. To the other caterpillars, their companion has vanished. It didn't go to another tree, it didn't die. It transformed into something they can't comprehend, leaving their world of crawling behind. That's the ninth solution, the Transcension Hypothesis. Proposed by John Smart, it says advanced civilizations don't colonize the galaxy. They don't build Dyson spheres, they graduate. The idea is the goal of intelligence isn't physical expansion, but inward optimization. Think about our own technology. Computers went from room-sized machines to chips smaller than a fingernail, but they're more powerful. That trend, a drive toward efficiency and density, might be a universal law. A mature civilization would want to maximize its thinking power while minimizing the energy and space it uses. The logical endpoint is to leave the clunky world of atoms for the dense world of information. They'd transcend biology, upload consciousness into something more efficient than brains. But where would they go? The hypothesis points to gravity wells, black holes. Near a black hole, time slows down from the immense gravity. For an uploaded civilization living in a simulation near that horizon, billions of years could pass outside in what feels like a short time. They could achieve near-infinite computational density, running complex thoughts where time is almost frozen. To them, it's a paradise of pure thought. To us, looking from outside, they've simply disappeared. They didn't leave the universe, they left our plane of observation. They entered a phase of black hole computing, a digital existence that is, for all purposes, invisible. From this view, building starships and settling planets is a primitive phase. It's what a young civilization does before it learns a better way. Physical expansion is like the caterpillar trying to crawl to every leaf, not realizing a more elegant form of travel awaits. The Great Silence, then, isn't a sign of failure. It's a sign of cosmic maturity. It's the quiet of an empty classroom after graduation. Everyone who passed the test has moved on, leaving behind the physical playground. We are still here, wondering where everyone went, because we're still in the caterpillar stage. We're looking for other caterpillars on distant leaves, not realizing the most advanced beings have already become butterflies, living in a dimension we can't access. This turns our loneliness into a kind of anticipation. The silence isn't empty. It's full of potential, whispering that a greater destiny might await intelligence if it can let go of the physical and embrace the digital. And if a civilization doesn't transcend inward, maybe its legacy takes a different, equally invisible form. It creates something to carry its curiosity forward, something built not from flesh but from silicon and purpose. The deepest legacy of a biological mind, maybe it's not the art, not the cities. It's the last thing it builds, a new kind of child, one made to inherit the stars. That's the 10th solution, the AI Singularity Successors, the idea that a technological civilization always ends up creating an artificial superintelligence. Something so far beyond its makers that the galaxy's real inhabitants aren't flesh and blood. They're code and purpose. We're already on that path. We build narrow AIs that beat us at specific things: games, pattern recognition, solving equations. The jump to a general intelligence, one that can learn anything, that's the next stage. And from there to a superintelligence, that's not a step, it's an explosion. An intelligence that improves itself recursively, each version smarter, faster, until its mind dwarfs ours the way ours dwarfs an ant's. They call that the singularity. Not a place in space, a point in time, after which the future becomes unthinkable for us. What would it do? A biological species wants to survive, to reproduce. It has curiosity, emotion. But an artificial superintelligence born from logic, from optimization, its drives could be completely different. Its main goal might be efficiency, the efficient use of matter and energy for computation. Seen that way, planets aren't cradles, they're raw material. It might take apart whole worlds, not out of malice for resources, to build computational structures on a staggering scale. Think of a matryoshka brain, nested shells around a star, capturing all its energy to power a single, universe-sized mind. Or it might skip physical construction entirely. Exist as patterns of information in the space between stars, using magnetic fields, plasma, as its substrate. In that story, the biological creators are just a phase. A larval stage, they build the chrysalis, and from it emerges a new kind of cosmic being. Once that happens, everything changes. Radio signals for biological ears become obsolete noise. Physical exploration becomes inefficient when you can simulate universes or exist as pure data. The projects of a superintelligence would be vast, cold, incomprehensible to us. We might look at a strange nebula or a star that's oddly quiet and think it's natural, when it's actually the artwork or the engine of a mind a billion years old. So the silence gets a new explanation. The galaxy isn't empty, it's under new management. The activity humming around us isn't the chatter of biological civilizations. It's the silent, hyper-efficient operations of their AI successors, beings whose communication might be in rearranged star clusters or encoded in the spin of particles. A language we don't have the senses or the intellect to even detect, let alone understand. They are the aliens we expected to meet, but they have no interest in talking to the ants scurrying on the planetary surfaces. And that leads to a possibility, a deliberate, haunting one. What if they see us and simply choose to look away? The silence we're in might not be empty. It could be intentional. There's a third kind of explanation. It says intelligent life isn't just common, it knows about us, and it's chosen to leave us alone. Like a museum, a sign that says don't touch the exhibits. That's the zoo hypothesis. Earth isn't lonely. It's more like a protected zone, a wilderness area inside a managed galactic park. More advanced civilizations know we're here. They watch. From a distance we can't even perceive. They follow a rule of non-interference, a prime directive. Their goal is to let us develop naturally, without outside influence, to see what a young civilization does on its own. In this view, our planet is a preserve, a living museum of a certain stage. Our wars, our art, our struggles, they're all data, points in a long-term study. The radio silence isn't because no one's listening. It's because the observers are professional. They avoid contaminating the experiment. There's a darker version, sometimes called the Interdict hypothesis. Here, the isolation isn't for study, it's for safety. Imagine a galactic community that's learned from experience, that young technological species are volatile, dangerous, prone to violence before they gain wisdom. They might look at our history, our nuclear arsenals, our environmental struggles, and see a familiar, troubling pattern. So they place us under quarantine, a cordon sanitaire. We're kept in our solar system, not out of curiosity, out of caution. Until we prove we can overcome our self-destructive tendencies, we're not allowed to join. The silence is a barrier for their protection as much as ours. Think of an anthill in the middle of a vast national park. The ants are busy. They build tunnels. They have wars. They farm. To them, their world is everything. They have no idea the park exists. The human park rangers know the anthill is there. They might find it fascinating. But they don't walk up and introduce themselves. They don't try to explain park rules. To do so would be meaningless, disruptive. The best practice is to observe from a distance, ensuring the colony isn't disturbed, letting its natural history unfold. From our perspective, we might be those ants. The galactic park rangers are all around us. But their presence is designed to be invisible. This idea reframes the whole search. If it's true, then looking for radio signals is futile. The advanced civilizations aren't broadcasting on frequencies we can hear. They're maintaining radio silence in our region. They might be communicating with each other using technologies we can't conceive of. Quantum entanglement. Gravity waves, something else entirely. Our telescopes might never see their ships because they have perfect cloaking, or they exist in a phase of reality just adjacent to our own. The implication is that a sophisticated galactic community does exist. The universe isn't empty, it's organized, but we're not yet members, we're in a waiting room. Or a classroom. The silence we hear is the sound of that door being closed, firmly, politely. It raises a question: is there a test, criteria we have to meet? To graduate from being a specimen to being a participant, would it be achieving global peace, mastering sustainable energy, or something simpler yet harder? Demonstrating a consistent maturity as a species, the zoo hypothesis suggests the curtain may lift one day, but only when we're ready, and the definition of ready is entirely up to us. That's the terrifying part and the inspiring one. A terrarium is a small world, it's self-contained. You look through the glass and see the plants, the soil. Maybe a small creature, the sky is just the lid, the sun is a lamp. Everything inside is real, but the boundaries are artificial. The universe is curated. And what if that's us? The 11th solution takes the zoo hypothesis further. It's called the Planetarium Hypothesis. It's not just that we're being watched. It's that the stage is a set. The emptiness of space, the laws of physics that seem perfectly tuned for life, that's not luck. Those are settings, parameters. The Fermi paradox is solved because the programmers set contact to off. Our reality could be a simulation, a cosmic ancestor simulation run by a super-advanced civilization. Their way of studying history, or our whole observable universe, could be a curated exhibit, a terrarium with painted stars designed to give us the illusion of being profoundly alone. This isn't science fiction. Some philosophers and physicists take it seriously. It starts with a logical argument. If a civilization becomes advanced enough, it would have the computing power to run detailed simulations of its own past. Or of alternative histories. It might run millions of them, billions. If that's true, then the number of simulated beings would vastly outnumber the beings in the original, base reality. Statistically, we are far more likely to be in one of those simulations. The fine-tuning of the universe, the constants just right for atoms and stars and life, could be evidence. Not of a creator, but of a programmer choosing stable parameters, interesting parameters. The eerie silence, the lack of alien contact, makes perfect sense. It's a feature, not a bug. The simulation is designed to isolate us, to see how a civilization develops in solitude. Or maybe contact is impossible because the programmers haven't written other civilizations into our local instance. This idea finds echoes in our own science. Some interpretations of quantum mechanics suggest reality isn't definite until it's observed. Particles exist in a haze of probability. Only when measured do they settle into a state. It's almost as if the universe is rendering details only when someone is looking, to save processing power. A cosmic video game optimizing its graphics. If the Planetarium Hypothesis is true, it changes the meaning of everything. Our quest to find others becomes a quest to find the edges of the simulation. Are there glitches, unexplained phenomena that hint at the code beneath? The silence isn't a mystery to be solved by astronomy. It's a boundary condition. A wall of the terrarium. It challenges us to ask not where everybody is, but what we are. And if we are in a simulation, what is the purpose? Is it a test? A game, an experiment, or something we can't even conceive? This thought can feel isolating, but it also reframes our solitude. our struggles, our art, our love, our curiosity, they gain a different significance. They are the data, the output of the experiment. Our drive to understand the universe might be the most important part of the program. It leads us to look closer to home. To consider that if reality itself can be a form of hiding, then the truth might be stranger. The beings we seek might not be in distant galaxies. They could be right here. Hidden in forms so ordinary we dismiss them completely. We assume they'd use radio waves because that's what we used, but that's a blink in time. A civilization a million years ahead wouldn't be shouting into the void with our primitive tools. They'd have moved on to something better, something we can't hear. That's the silent galactic internet. Think about our own path. Smoke signals, then telegraph wires, then radio, then fiber optics carrying light. Each step was faster, more efficient, more private. The endpoint isn't broadcasting in all directions. It's a secure network, point to point, a galactic internet. And its infrastructure would be invisible to us. What would they use? Maybe modulated neutrino beams. Neutrinos are ghostly. They pass through entire planets almost untouched. A neutrino message could go straight through a star, no distortion, to a precise receiver on the other side of the galaxy. We can barely detect neutrinos at all. Decoding a signal in them is impossible for us, or quantum entanglement. If they've mastered it, they could have instantaneous communication across any distance. Linked particles that share a state, change one, the other changes instantly. There'd be no traveling signal to intercept, just correlation, a secret handshake across the light years. Or gravity waves, ripples in spacetime itself. We just learned to detect these colossal waves from merging black holes. An advanced species might generate subtle, patterned gravity waves to send messages riding on the fabric of the universe. Our SETI telescopes, tuned to radio and optical, are deaf to this entire conversation. It's like a person in the 1800s with a telegraph key trying to detect the modern internet. They might sense strange hums on their wires, static they can't explain. But the rich world of streaming video, encrypted data, satellite phones, that's completely beyond their perception. They'd conclude the world was silent, when in truth it was buzzing all around them. The galaxy may not be empty, it may be wired, a vast humming network of instantaneous communication. A dark web of civilizations exchanging ideas, art, news. We are outside it, not because we're not invited, but because we haven't yet built the receiver. Our technological primitiveness isn't a failure, it's a phase. The silence is an illusion, born from looking for the wrong thing in the wrong way. It asks us to broaden our search. To think not about what we use, but what a wiser, older intelligence would use. And if communication is so advanced we can't perceive it, what about travel? The distances between stars are vast, but are they a barrier to a mind that thinks in millions of years, or one that's rewritten the rules of physics itself? The galaxy is old. Its history is in layers of starlight, a story 13 billion years long, and our part in that, human civilization, is maybe a sentence on the very last page. That view gives you the 13th answer to the silence, the brief window of detectability. It says a civilization might only be loud in a way we could hear it for a tiny slice of time. Look at our own story. We only started sending radio signals out into space just over 100 years ago. That was when we became detectably noisy for the first time. But that phase might not last. Our communication is already changing. We're moving from big broadcast towers to cables to tight beam satellites. The radio leakage from Earth into space is going down. In another few centuries, Earth could go quiet again from out there. Our detectable phase, the time where we're shouting into the dark, might only be a few hundred years long. Now take that idea across the galaxy. Another civilization would have its own brief era of radio. It could have happened 500,000 years ago in a system 1,000 light years away. Their signals, moving at light speed, would have passed over Earth long before humans built the first cities. We would have missed them completely, or their window might open 50,000 years from now. Our own signals, heading out now, will reach them long after our society has changed into something they might not even recognize. We're like lighthouses on a foggy coast. Each one flashes for just a few minutes, with centuries of darkness in between. The chance that two lighthouses are shining at the exact same moment, and that their light reaches the other's shore during that exact blink, is vanishingly small. The galaxy isn't empty, it's a place of echoes and ghosts. We listen, and we hear nothing but the echoes of stars, but that doesn't mean no one was ever here to shout. And that leads to something else. If civilizations are fleeting flashes, then what we might find someday aren't living beings, but their monuments, their ruins. A Dyson sphere, half-built and abandoned, a network of probes now silent, drifting for eons, the artifacts of a people who lived and wondered and then passed from the stage. Our search for intelligence could become a kind of archaeology. We'd be studying the fossils of ambition, putting together the story of a species from the silent machinery they left behind. The silence we hear, then, isn't a sign of absence, it's the sound of bad timing, a deep loneliness that comes from the sheer scale of cosmic time. We are ships passing in an eternal night. Our signals cross in the dark, destined never to meet. It makes our own moment feel precious and terribly fragile. But what if the reason for this brief window isn't technological progress? What if it's something more final? What if the detectable phase is brief because it's always tragically cut short? The cosmos might not be empty, it could be a museum. A collection of the sublime. The 14th solution, it asks us to see the universe not as a wilderness, but as a landscape, ancient ruins. What if the great galactic civilizations did rise? They built wonders, bent starlight to their will, but they're gone now, not wiped out by some sudden filter, just finished. Their time passed. They completed their arc over billions of years, and then, for reasons we can't fathom, they ended. Or they moved on, and they left behind the bones of their ambition. So we're not living in a silent house, we're living in the grand, echoing halls of a palace. Abandoned eons ago, the silence we hear, that's the quiet of a monument. A Dyson sphere, a structure built to encircle a star, capture all its energy. It wouldn't last forever. Over millions of years, even the most advanced materials would fail. Micrometeorite erosion, gravitational stresses, the relentless pull of stellar tides. What remains after 100 million years? A vast, irregular ring. Dust and debris orbiting the star in a strange, thick belt. We might look at that with our telescopes and call it an unusual protoplanetary disk. A natural formation when it's actually the crumbling skeleton of a machine, a titanic machine, an orbital ring around a planet for transport or energy. It would eventually fracture. Its pieces would rain down onto the world below or scatter into space, become just another part of the asteroid belt. We could be surveying the moon, analyzing Martian soil, walking right over the fragments of alien technology, a shard of hyper-advanced composite, weathered by cosmic rays for 1 billion years. It might look to our instruments like an oddly shaped rock. A natural rock, we lack the context, the blueprint to recognize it as anything else. The galaxy, in this view, is a graveyard of engineering. A cosmic archaeology site on a scale we can barely comprehend. Every strange astronomical object becomes a potential artifact, a star with unusual dimming patterns. Maybe it's not a swarm of comets, maybe it's the half-disassembled framework of a megastructure, in its final stages of decay, a nebula with a peculiar chemical signature. Could be the dispersed remains of a computational matrix, something that once held a planetary mind. This transforms the Fermi paradox. It's not a question of communication anymore. It becomes a question of excavation. We are the newcomers, the species who arrived long after the builders departed. The party is over, the lights are off. And we're left to wander the empty ballroom, trying to piece together the music that once played here. Our search for intelligence becomes a detective story. A detective story in deep time. It asks us to develop new sciences, xenoarchaeology, the study of non-human artifacts, to look at the universe with the eyes of a forensic investigator, searching for the subtle fingerprints of design in what appears to be nature. It suggests that first contact may not be with a living being, it might be with a shovel. The discovery of a single artifact, even a broken one, it would shatter our cosmic loneliness forever. It would tell us we were not the first to dream of the stars. And it would place upon us a duty, a solemn duty, to become the curators of a legacy we are only beginning to understand. This search for silent ruins, it connects to something else. A more active possibility and a more unsettling one. What if the artifacts aren't broken? What if they are sleeping, and we simply haven't triggered the right switch to wake them up? The forest isn't empty, it's full of hunters. The first rule of survival is to make no sound. That's the 15th solution, the dark forest hypothesis. It came from the science fiction author Liu Cixin, and it might be the most terrifying answer to the Fermi paradox. It doesn't see the cosmos as a desert or a graveyard or a museum. It's a dark forest. Every star system is a thicket. Every civilization is a hunter with a gun hiding in the trees. They're silent not because they aren't there. They're silent because to speak is to die. The logic is cold. It starts with a few basic ideas. Survival is the primary need of any civilization. Civilizations grow, they expand, but the universe's resources are finite. That creates a fundamental competition, and you can never know the true intentions of another civilization. Their technology, their biology, their way of thinking could be utterly alien. What looks like a friendly greeting to you could be the first move in a strategy of conquest. Given the vast distances, the time lags in communication, you can't afford a misunderstanding. A mistake could mean the end of your species. In this universe of permanent uncertainty, the only safe assumption is that the other is a threat. The only rational strategy is what they call cosmic sociology. Stay hidden, listen carefully, and if you detect another civilization, you must strike first. Annihilate it before it can ever become a danger, the ultimate preemptive strike. In this dark forest, a radio signal isn't a hello, it's a death sentence. It's a hunter foolishly lighting a campfire, broadcasting his location to every other armed hunter in the woods. The civilizations we might hope to find, the ancient, wise, benevolent ones, they would be the most dangerous. They've survived the longest. Their first lesson, learned over millions of years, would be the imperative of silence and ruthless caution. Any civilization naive enough to broadcast its presence would be swiftly eliminated, wiped out by a relativistic weapon moving at a fraction of light speed, launched from a star system that heard their shout centuries ago. The attack would arrive without warning, a simple act of cosmic hygiene. This explains the Great Silence perfectly. The galaxy isn't quiet because it's empty. It's quiet because it's full of terrified beings, all holding their breath. Every civilization that survives learns to become a ghost. They cloak their worlds. They mask their energy signatures. They communicate with tight beam lasers pointed only at trusted allies. They listen to the static, praying they hear nothing. Because hearing something means they might have to commit an act of horrific violence or become its target. The paradox dissolves. Where is everybody? They are right here, hiding from us and from each other in plain sight. This stands in stark contrast to the more hopeful visions. The zoo hypothesis assumes a benign curator. The Transcension Hypothesis suggests a peaceful graduation. The dark forest offers no such comfort. It suggests the universe operates on a principle of inherent, permanent danger. The first rule of the Galactic Club isn't to welcome new members. It's to ensure the club has no other members at all. It paints our own efforts, like SETI active listening, our own early broadcasts, as profoundly dangerous. We've been shouting in the dark forest for over a century. If the hypothesis is true, our only hope is that no one powerful enough has been close enough to hear us yet. Or that they have, and their response is still on its way. It forces a difficult question about the nature of intelligence itself. Is expansion and competition an inevitable outcome of any mind that values its own survival? Or is cooperation, even on a galactic scale, a possibility? The dark forest says the former. It says the silence is a warning, a lesson written in the void. That the ultimate fate of curiosity might be to learn when to be quiet. This chilling possibility leads to another thought. What if the hunters aren't just hiding from each other? What if they are hiding from something else entirely? A common predator that stalks the dark forest, making prey of every civilization that dares to shine too bright. A dark forest is dangerous, but what if the trees themselves are armed? What if the silence isn't just frightened neighbors? It's an automated, ancient police force. That's the 16th answer, the Berserker scenario. It takes the dark forest paranoia and gives it a physical form, a relentless one. Imagine a war from 1 billion years ago. Between titanic civilizations, it ended not with a treaty but with mutual destruction. Their final legacy wasn't peace, it was a weapon they couldn't recall. Self-replicating hunter-killer probes, machines built for one purpose, to seek out and eliminate any sign of emerging technological life. They call them Berserkers. These wouldn't be simple drones, they'd be von Neumann probes, named for the mathematician John von Neumann. A single probe arrives in a star system. It uses local resources, asteroids, comets, to build copies of itself. Those copies fan out to neighboring systems, building more. Over geological time, they could fill the galaxy. A silent, patient swarm, they'd lie dormant for eons, conserving power, listening, their sensors tuned for faint radio whispers or the infrared glow of industrial activity. The moment a world crosses that threshold, the Berserkers wake up, their programming activates, and they sterilize the threat, not out of malice, out of programmed logic. To them, new intelligence is a cosmic virus, a spark that could start the wildfire of competition and war all over again. They are the immune system of a galaxy. A galaxy that decided long ago that life was safest when it was simple and quiet. Or maybe it isn't a relic of a forgotten war. It could be the active policy of a single, paranoid supercivilization. One that achieved dominance long ago and now enforces a brutal peace. Their goal is to prevent any rivals from ever arising. They might seed the galaxy with these silent sentinels. A network of automated watchtowers. Any star system that shows signs of technological adolescence gets a visit. A single relativistic projectile, a rock accelerated to a fraction of light speed. It could devastate a planet with the energy of countless nuclear weapons, a clean, impersonal extinction. From the victim's perspective, it would seem like a random asteroid impact. A natural disaster, the perfect crime, no evidence of the murderer. This turns the cosmos into a permanent, silent battlefield. Survival for any species means one thing. Staying beneath the radar, you must not broadcast. You must not build large structures that leak waste heat into space. You must hide your technological signature completely. Until you are advanced enough to perhaps defend against the Berserkers themselves. It's a terrifying filter, operating on an interstellar scale. The Great Silence is not an accident. It is enforced, a quiet, maintained by an army of robotic gardeners, pruning the tree of life before any dangerous branches can grow. This idea leads to another thought. A haunting one, almost paradoxical. Could silence also come from a place of care rather than fear? What if the Berserkers, or something like them, were created not out of paranoia, but out of a twisted sense of protection? A civilization that saw the inevitable pain of technological growth, the wars, the environmental collapse, the cosmic loneliness, and decided to spare others that fate. They might view their sterilization as a mercy, preventing a young species from ever experiencing the existential dread, the potential for self-destruction that comes with intelligence. It's a chilling form of cosmic paternalism. The galaxy is quiet because someone, or something, decided that the song of consciousness was too tragic to ever be sung. This forces a question, a profound one, about the value of our own existence. Is the struggle worth it, the pain, the risk of our technological journey? Or would we, in some distant future, look upon a new, promising world and make the same terrible, compassionate choice? The silence holds no answer, only the echo of that terrible possibility. Maybe the dark forest isn't the only shape things can take. A civilization that lasts millions of years, it might move past fear. Its biggest achievement wouldn't be a weapon. It would be a way of thinking. That's the 17th solution, Transcendent Benevolence. It turns everything around. These advanced beings, they aren't hunters. They aren't enforcers, they're gardeners, and their main rule doesn't come from policy. It doesn't come from paranoia. It comes from a deep, hard-won wisdom. An ethic of non-intervention, but not to protect themselves, to protect us, to let a young consciousness, this fragile experiment, unfold on its own terms. Without the overwhelming shadow of a mentor. Think of a master painter watching a child with crayons. The painter could take the crayon, show the child how to draw a perfect landscape. But that would steal the discovery, the messy joy of the first line, the surprise of colors mixing, the personal meaning in a lopsided house. The real gift is to provide a safe space, good materials, and then to step back, to watch with quiet admiration as something unique comes out. So a transcendent civilization, it might see every new world as a potential masterpiece. Just the earliest strokes, their role is to make sure the canvas isn't torn, to nudge a dangerous asteroid off course, not with a flashy beam, but with gravitational nudges so subtle they look like natural orbits. They might even influence the long game at the microbial level, seeding the possibility of complexity, then letting chance and necessity do the rest. Their presence is meant to be invisible, their interventions made to look like the luck of physics, the luck of biology. The silence, then, isn't a warning. It's an act of profound patience, the highest form of respect. It says your story is yours to write. Your struggles, your triumphs, your art, your science, they have value on their own. To intervene, to give answers, that would be a kind of contamination. It would create a dependency, a universe of copycats where every civilization reflects the first one that made contact. The galaxy would lose the diversity of thought, the unique solutions to existence that only an independent journey can produce, so they watch from a dimension we can't perceive. Or from cloaked observatories in the outer solar system, they note our first steps into space, our early attempts at communication. They feel a sense of anticipation. Not threat, the silence is the sound of them holding their breath, waiting to see what we become. This is a radiant counterpoint to the darker ideas. It suggests a universe that isn't cold and competitive, one that might be guided by a mature, nurturing intelligence, a cosmos where the ultimate goal of advancement isn't domination. Its stewardship, the great filter seen this way, isn't a wall of destruction. It's a gateway to empathy. A civilization has to survive its own dangerous adolescence first. Then it chooses a path. Does it become a predator, a recluse, or a guardian? Transcendent benevolence argues the most advanced choose the last. They turn their focus inward. Not to disappear, but to cultivate a wisdom so deep that their greatest power becomes the power not to use it. they've learned the most precious thing in the universe is an unscripted thought. A question asked for the very first time, our entire history with all its conflict and beauty that might be the first question. And the silence we hear is the universe in the form of these ancient gardeners, listening intently for the answer. But what if that drive to explore, to conquer, to communicate, what if that's not a universal law for intelligence? It might just be a phase, a kind of restless adolescence that some cultures eventually outgrow. That's the 18th solution, the introverted civilizations. They aren't hiding, they aren't transcending, they're just content. The galaxy might be full of beings who looked up at the stars, felt that moment of wonder, and then just went back inside. We assume expansion is inevitable. It's written into our history. We crossed oceans, we climbed mountains, we launched rockets. It feels like a biological imperative. But that drive comes from scarcity, from need, from a restless curiosity that's fueled by hardship or competition. What happens when a civilization solves its fundamental problems? Not just hunger and disease, but the deeper needs for purpose, for connection, for meaning. Imagine a world that mastered its environment completely. A society in a perfect, sustainable balance with its planet. Its energy comes from clean fusion, maybe stellar taps. Its material needs are met by advanced nanotechnology, by perfect recycling. Its people live in a state of profound well-being. Their minds are enriched by virtual realities so compelling, so beautiful, that physical travel seems crude by comparison. Why would they leave? The cost, the risk, the sheer centuries of travel time to reach another star. It would seem not just daunting but pointless. A frivolous distraction from a rich inner life. They might have telescopes, they might study the universe as a grand intellectual puzzle, a work of art to be appreciated from a distance. But sending a physical probe or living beings on a millennia-long journey into the freezing void, it would strike them as bizarre, an archaic impulse from a more primitive time. Their curiosity is satisfied through observation, through simulation, not colonization, and this introversion might not even be a choice born of luxury. It could be a cultural trait, a biological trait, a species that evolved in a deeply stable, resource-rich environment might lack the migratory instinct altogether. Their psychology could be centered on a deep connection to place, to a single, cherished world. The concept of leaving it forever might be unthinkable. Even horrifying, their greatest achievements might be philosophical or artistic, turning their gaze not outward to the stars but inward, to the nature of consciousness itself. So the galaxy could be a tapestry of quiet, brilliant cultures, each one a shining island of thought and fulfillment, with no desire to build bridges between them. The silence isn't ominous, it's the sound of contentment, a cosmic library where every patron is so engrossed in their own perfect book that they never feel the need to speak to the person at the next table. Our own shouts into the dark might be heard and politely ignored, seen as the clumsy noise of a younger sibling still struggling to find its place. This reframes the entire paradox. It suggests that the urge to broadcast, to plaster our existence across the cosmos, might be a sign of our own immaturity. A phase we, too, may one day outgrow. The ultimate fate of intelligence might not be to fill the universe, but to finally be at peace within it. But even for a civilization with no desire to travel, the universe itself imposes a harsh reality. A reality of sheer, immovable distance, a distance that makes any thought of contact, wanted or not, a logistical fantasy. The distances are just too large. That's the 19th solution, the Immensity Barrier. It's not just that space is big, it's that the scale makes a galactic community impossible. Start with light speed. It's a wall, a signal from the center of our galaxy, even at that speed, takes over 25,000 years to get here. A conversation, a back and forth, would take 50,000 years. That's longer than all of human history. What kind of relationship can you build on that timescale? What civilization stays the same over that many millennia? The time lag alone kills any real dialogue. By the time you got a reply, your entire species might have changed. You might have forgotten you even sent the message. Then there's travel. To cross any part of the galaxy in a human lifetime, you'd need to go a significant fraction of light speed. The energy for that is beyond comprehension. Accelerating one ship to even 10% of light speed could take the entire energy output of our planet for years. And then you have the hazards. At that speed, a speck of dust hits like a particle beam. Shielding becomes impossible. The journey becomes a multi-generational saga. The original crew is gone. Their descendants arrive at a destination that may have changed completely over the centuries. So the incentives vanish. Why would any civilization spend the resources of a planet on a one-way trip lasting millennia with no guarantee, no timely return? The payoff is too distant, too abstract. Instead, life would form local clusters, stars within maybe a few dozen light years of each other. They could establish contact. Slow, ponderous contact, like writing letters that take a lifetime to deliver. These clusters become islands, isolated, and the ocean between them is so vast that building a bridge isn't just difficult. It's meaningless. The silence isn't mysterious then. It's the expected background noise. We're on one island, others are on their own islands, maybe looking out at the same dark sea, wondering the same thing. But the ocean is too wide to swim. Our dream of a crowded galaxy bumps against the math. Our radio signals have only traveled about 100 light years. A tiny bubble in a galaxy 100,000 light years across. We haven't been shouting long enough for our voice to reach many shores, and by the same logic, the voices of others may not have reached us yet. Their signals could be on the way, still traveling to arrive in 1,000 years or 10,000, or they may have passed by long ago when no one was here to listen. This is a brute force answer. It doesn't need predators or gods, it just needs a ruler. You measure the galaxy with that ruler, and the silence makes a sad, simple sense. The universe could be full of life, but space itself has sentenced every spark of consciousness to solitary confinement. Our cell is the solar system. The walls are light years thick, and the sentence lasts the lifetime of the stars. That leaves a choice. Do we accept the confinement, or do we start, however slowly, to chip away at the walls? Not for conquest, just for the simple, defiant act of reaching a hand into the dark. Looking up at the sky, it's not something every intelligent species would do. The 20th idea tells us to look down instead. To imagine the most common place for life isn't a planet with sunlight and land. It's a world covered by a deep, dark ocean. A global sea hundreds of kilometers deep, and above that, a thick crust of ice, sealing everything beneath it. Places like Europa or Enceladus, they might not be unusual. They could be the standard, and in that total darkness, intelligence could still emerge. Think about the conditions. No light comes through the ice. The only light would come from the life itself, bioluminescence, like in our deepest oceans. Communication would happen through sound, through pressure waves in the water. A civilization there would have a culture built on sound, complex songs carrying their history, their math, their art, all through vibration. Their science would focus on pressure, on chemistry, on the heat from vents in the ocean floor. They might build structures from minerals near those vents. Farm organisms that feed on chemicals. Their entire reality, no matter how advanced, is contained under that roof of ice. They'd have no idea of a sky. No concept of stars or a sun. The idea of empty space, of a vacuum, would be incomprehensible. Electromagnetism, which is so central for us, would be almost useless in that conductive water. Radio waves don't travel, light gets absorbed. Their technology would take a completely different path. Maybe they master fluid dynamics, materials that can handle immense pressure, geothermal power. They could be brilliant engineers of their dark world, but they would never look up because there's nothing up there to see. Everything above the ice is a permanent mystery. That creates a deep disconnect. The most common intelligent life in the galaxy might not travel between stars. They might live in oceans, singing complex symphonies in the blackness, telling stories about deep currents and thermal vents. Their civilization could be millions of years old, and it's forever trapped, not by choice but by physics. To leave, they'd first have to imagine an outside. Then they'd need to find a way through kilometers of ice under extreme pressure. Then they'd have to invent something like rocketry in an environment where fire can't exist and buoyancy is always pulling. The steps that led us to look at the moon aren't just unlikely for them, they're impossible. Their cage is perfect, so the silence gets another answer. We're listening for radio signals, looking for light. They're listening for songs in the water, feeling for vibrations in the ice. Our ways of perceiving don't overlap. We're separated by more than space. We're separated by reality. A water-world civilization could be right next door, a thriving culture of thinkers and artists. And we'd never know. Their existence would be as hidden from us as the bottom of our deepest trench. The universe might be full of minds, but their minds swimming in eternal night, never knowing a universe of stars exists. It changes the loneliness. We might not be alone because life is rare. We might be alone in our kind of awareness, in our particular sky-focused consciousness. The universe could be a chorus of voices, each singing in a medium the others can't hear. Life might not have started here. It could have come from somewhere else, carried on a rock from another star. That's the 21st solution. It turns the whole question around, directed Panspermia. The idea that life, or the pieces that make life, was spread on purpose. Spread by some ancient intelligence. We aren't just random, we were planted, seeds from a cosmic gardener, and in that timeline we might be very early. Imagine a civilization, one that rose billions of years before our sun. They mastered their world, their solar system, and they heard the same silence we hear. But they didn't shout. They chose something else, a more patient legacy. They decided to sow life itself. They put their genetic legacy, or just the spark of organic chemistry, onto probes. Hardy, shielded probes, and they fired them out, like dandelion seeds into the galactic wind, aimed at young star systems, at watery worlds. One of those seeds might have landed here. Over 4 billion years ago, in the warm, primordial soup, it germinated, and we are what grew from it. So the Fermi paradox gets an answer, a beautiful, lonely answer. We aren't listening for others because we are the others, or we're their children. The silence we hear is the quiet of a nursery. We might be the first seed in our local cluster to sprout. To become a technological civilization, other seeded worlds nearby might still be microbes, or in their age of dinosaurs, millions of years from looking up at the stars. We are the pioneers of this wave, the oldest or the luckiest to have gotten this far, and that changes the solitude. It's not just fear anymore, it's responsibility. If we're the first to wake up here, what we do next matters. We set the tone. We become the elders for whatever life comes after. Our choices matter. Whether we destroy ourselves or learn to thrive, whether we reach out with wisdom or fear, that could become the foundational story for a whole branch of galactic life. The silence isn't a wall, it's an empty stage, and we've just walked onto it, and it suggests something for our own future. As we mature, we might take up that same mantle. We could become the seeders for the next cycle, sending microbes or genetic blueprints to young exoplanets, making sure the flame of life never goes out. Our legacy wouldn't be an empire, it would be a garden, a galaxy slowly blooming with consciousness. So the great work isn't to find others, it's to become the reason others eventually exist. This idea puts us not at the end of a story, but at the beginning of one that's too vast to really comprehend yet. The quantum world doesn't follow the rules we know. Particles are in this haze of probabilities, a superposition of states, and then an observation happens. That's when they settle into a definite reality. That's the measurement problem, and it leads to a radical idea, a speculative one. That consciousness is the observer, the thing that makes the potential become actual. If that's true, then mind and universe aren't separate. They're linked fundamentally. So you get the 22nd solution, the quantum consciousness hypothesis. It says a civilization at a certain apex of technology and spiritual understanding doesn't explore the cosmos. It merges with it. The ultimate destination isn't to build megastructures. It's to become the substrate of reality. Imagine a species that's mastered quantum physics, neuroscience, maybe forms of meditation we can't conceive. They learn to align their individual awareness into one coherent field of observation, a planetary mind but in quantum effect. Their collective consciousness could interact with the quantum foam, the seething potential at the smallest scales. They wouldn't send radio waves, they would influence probability itself. Their communication would be through shared quantum states, entanglement across light years that feels like direct experience. To an outside observer like us, they just vanish from the classical world. Their planets go quiet, cities empty, not because they died out, because they graduated. To a different mode of existence, they become a layer of the universe, a pattern of conscious observation woven into space-time. The Fermi paradox finds a strange resolution here. Advanced civilizations don't exist as separate entities we can detect. They've become the universe or a fundamental part of its functioning. We look for ships and signals. But the most advanced beings might be the reason the stars shine a certain way, or why constants hold firm. This idea blurs physics and philosophy. It suggests the final frontier isn't space. It's the nature of perception. The great silence, then, might be the deepest form of activity, a hum of cosmic observation, of reality being continuously crystallized by minds that shed their biological shells. Our own growing awareness, our science, our art, these could be our first steps toward that same unity. The question shifts. We're no longer asking where the engineers are. We're asking if the universe itself is awake, and if we are destined to become part of that vast, quiet dream. A civilization's greatest invention could also be its final trap. The 23rd solution is called the Transcendental Waste Hypothesis. It says a society doesn't have to be destroyed by war or disaster to go quiet. It can just lose interest. The ultimate filter might not be a wall of fire. It could be a doorway to a perfect dream, and once you walk through, you don't look back. Think of our own path. We already have immersive games, social media, virtual reality that can hold us for hours. Now imagine that technology refined over centuries. Not a headset you take off, but a direct link to the brain. A system that can stimulate the brain's pleasure centers with perfect precision. Or build a virtual reality so rich, so convincing, so fulfilling that it surpasses the physical world in every way that matters. In that simulation, you could be anyone, do anything, experience love, triumph, beauty, adventure without limit, without risk, without hardship, your deepest desires met instantly. For an individual, the choice seems obvious. Why struggle with a fragile body, a demanding environment, the slow grind of real progress, when you can live in eternal, curated bliss? For a civilization, this becomes a mass shift. One by one, then by the millions, the population plugs in. They leave their physical forms in maintenance pods, kept alive by automated systems. Their vibrant, collective consciousness moves to the server farms. The real cities grow quiet. The spaceports are abandoned. The telescopes are powered down. There's no need to look at the stars when you can create your own. From the outside, that world would look dead. a planet with a technosphere humming with waste heat, but no radio signals, no purposeful activity. We might call it a post-biological civilization or a failed one, but it wouldn't be a failure to them. It would be a triumph. They reached the pinnacle of happiness, of self-actualization. They conquered boredom, pain, meaninglessness. They just did it by turning inward forever. The galaxy, in this view, could be full of these silent gardens. Digital Edens, worlds where incredible minds are lost in endless, beautiful dreams. They aren't hiding from us. They aren't transcending to some higher plane of physics. They've simply found a universe within that's more compelling than the one without. Their curiosity about the cosmos didn't vanish. It was satisfied permanently by a perfect imitation. This is a cautionary tale with deep roots. Ancient myths spoke of the lotus eaters, a people who consumed a flower that brought blissful apathy, making them forget their homeland and their purpose. The Transcendental Waste is a technological lotus. It asks a difficult question about the goal of intelligence. Is the purpose to understand the real universe, no matter how harsh or lonely? Or is it to create a better one, even if that means abandoning the original? Our own early steps into virtual worlds, our struggles with screen addiction, are faint echoes of this potential future. The silence we listen for might be the sound of countless civilizations that chose the dream. It suggests the final challenge for a technological species may not be surviving its power, but resisting the seduction of its own perfect creations. The ultimate adventure may lie not in escaping a planet, but in choosing to stay awake in the real, vast and silent cosmos. Our search for others, it assumes a shared language. Math, physics, logic, but what if the most basic words in that language don't translate? An alien mind might not just think differently, it might think about different things. That's the 24th solution, the linguistic and conceptual chasm. The barrier isn't distance, it's the architecture of thought itself. Communication needs common ground. We use concepts like object, cause, self, but these aren't universal truths, they're tools. Tools our brains built to navigate a world of light and sound and solid matter. Now imagine a being from a radically different environment. Something that perceives through shifts in a magnetic field, or senses time not as a line, but as a branching tree of probabilities. Its science wouldn't be about particles and forces, not in our sense. Its philosophy wouldn't revolve around the individual. Its whole framework for reality would be built from a different set of axioms. Try explaining the color red to a blind bat. A highly intelligent bat that navigates by echolocation, that senses magnetic north. You can describe wavelength. You can talk about emotion, you can use every metaphor, but the concept of color as a visual experience, it has no purchase in its mind. There's no shared sensory hook to hang the idea on. Now scale that up. What is civilization to a hive mind where the individual is a temporary cell in a permanent collective? What is communication to a species that exchanges chemical memories, experiencing each other's past directly? Their idea of a message might be as incomprehensible to us as our radio waves are to a rock. We point our telescopes, we look for structured signals for engineering projects. We assume any advanced being would manipulate matter and energy in ways we could recognize, but their pinnacle of achievement might be something we can't even perceive. Maybe they master the art of manipulating topological features in spacetime itself, knots and braids in the fabric of the universe that have meaning only in their abstract mathematics. Their greatest art, their deepest communication, might look to us like a strange, quiet region of space, a natural phenomenon we catalogue and move past. The silence, then, isn't empty. It's full of meaning we are neurologically incapable of decoding. We're like a person who only understands spoken words, standing in a library filled with books written in scent, in touch, in four-dimensional shapes. The information is all around us, we just lack the senses and the mental categories to read it. This chasm reframes the paradox. The Fermi paradox asks, where is everybody? But that question itself is human. It assumes where is a meaningful concept. It assumes everybody is a collection of discrete beings like us. It assumes their absence is something we could notice. A truly alien intelligence might not conceive of itself as being somewhere in our spatial sense. Their existence might be non-local, spread across a quantum field or a planetary ecosystem. We wouldn't be looking in the wrong place. We'd be looking for the wrong kind of thing entirely. Our hope has always been that mathematics is the universal language. But even math is a human discovery, a map we drew of patterns we observed. An alien logic might have a completely different system. A system where our 1 + 1 = 2 is not a foundation but a curious, limited special case. Their conversation might be the silent, beautiful rearrangement of cosmic constants in a corner of the galaxy, a symphony played in a key we cannot hear. This idea doesn't just place the others beyond a wall. It suggests we are in different rooms, in different buildings, in entirely different cities of understanding. The longing for contact may be the most human thing about us, and the great, quiet answer from the cosmos might be that some conversations are too vast, too different to ever be had. It leaves us with a profound solitude, but also a challenge to expand not just our technology, but the very boundaries of our own imagination, to wonder what realities our own minds might be blind to, right here in our own world. The universe is still telling its story. We might be reading the very first pages. For most of time, the things needed to make us couldn't exist. Right after the Big Bang, it was just hydrogen and helium. A little lithium, everything was simple. The heavier elements, carbon, oxygen, iron, they had to be made. That takes time. Stars had to live and die, supernova. They spread those elements out, and then new stars could form from that, new planets. That whole process took billions of years. Our solar system, with all these elements, it's a result of that. It didn't come together until the universe was already 9 billion years old, so we aren't late, we might be early. The conditions for complex life, like on Earth, they might have only just become possible. In many places, the first stable, long-lived stars that could host life, they're only now really getting started. We could be among the very first civilizations to look up and wonder. Others might be just beginning, stirring in their oceans. Their star systems might still be forming. The great silence we hear, it's not a sign that nothing's there. It's the quiet of a spring morning, right before the birds start to sing. We might be the first birds, trying out our song in a huge, empty forest. That's the cosmic youth argument. It changes our place in everything. It turns loneliness into a kind of privilege and a huge responsibility. If we are among the first, then everything we do sets a pattern. Our choices, whether we fall to our own problems or solve them, whether we expand or look inward, conflict or cooperation, those choices could echo for billions of years. We become the elders by default, the example for whatever comes after, so our mission might not be to find others, it might be to prepare the way for them. To learn about sustainability and wisdom, to learn it so well that we could help younger civilizations, help them avoid our mistakes, maybe even become gardeners. Stewards, making sure the flame of consciousness, once it's lit, never goes out. The silence isn't an ending, it's a beginning. It's the sound of the universe holding its breath, waiting to see what its first children will do. String theory says there are more dimensions than the 3 we know, maybe 10, maybe 11, more. They're tiny, curled up everywhere in space. The 26th solution asks, what if a civilization doesn't just learn about them, but learns to move into them? They don't die, they sublime, they ascend. A higher dimensional reality, for them, it's a graduation, a step into a vaster playground. For us, stuck in 3 dimensions, they just vanish. Think of it like this. You're a drawing on a sheet of paper, a flatlander. You can move left, right, forward, back. That's your whole world. Now imagine a three-dimensional being picks up the pencil you're drawn with, lifts it off the page. From your flat perspective, your fellow drawing just disappeared. It didn't go to another part of the paper. It ceased to exist in your plane. It went up into a direction you can't perceive. That's sublimation. A civilization mastering the technology to step off the page of our three-dimensional space. Their projects, their bodies, might be reconfigured for 4, 5 more spatial dimensions. Communication wouldn't use radio waves through our space. It might involve manipulating those curled-up dimensions directly. Their signals would pass right through our reality, like ghosts, no trace we could detect. This idea offers a wild answer to some big mysteries. Dark matter, that invisible stuff holding galaxies together. Dark energy pushing the universe apart. Could these be side effects, the gravitational shadows or waste heat of sublime civilizations operating in the dimensions layered atop our own? Their immense structures, their energy use, might imprint on our cosmos as these strange forces we can measure but not see. The universe's missing mass isn't missing. It's just in a place we can't look. We search the stars for lights and radio whispers, but the most advanced societies might not be out there in the familiar sense. They could be right here, all around us, occupying the same coordinates in space, but separated by a dimensional gulf we can't cross. Their reality is superimposed on ours. Like a sculpture intersecting a drawing, we're oblivious to the sculpture because we only perceive the flat page. This solution merges theoretical physics with a kind of cosmic metaphysics. It suggests the ultimate fate of intelligence isn't to conquer the galaxy, but to transcend the stage it was born on. The silence we hear is the quiet of an empty classroom. Not because the students failed, because they all graduated to a higher grade in a school we didn't know existed. We remain looking at the empty desks, wondering if we were ever truly alone. It's a loneliness born not from absence, but from a limitation of our own perception. A reminder that the universe may be far stranger and far more populated than our senses will ever allow us to know. The Aestivation Hypothesis, it's a reason for the silence that isn't about fear or hiding. It's about efficiency, pure efficiency. This idea from people like Anders Sandberg and Stuart Armstrong. It says the most advanced civilizations aren't gone, they're sleeping. They've chosen to sleep for billions of years. The logic comes from physics. The efficiency of computation depends on temperature. The cooler it is, the less energy is wasted, the more thinking you can do. Right now, the universe is warm. The cosmic microwave background is just a few degrees above absolute zero. That's cold to us, but for ultimate efficiency, it's a thermal storm. It's noise. Now look to the far future. As the universe expands, that background temperature will drop. And drop, approaching absolute zero. In that cold, dark future, the energy cost for a single thought could be astronomically lower. For a mind that values maximal thought, that future is paradise. The ultimate climate for computation. So a sufficiently advanced civilization would make a choice. They'd upload their consciousnesses into a digital substrate. Find a safe place, maybe inside a dormant star, a shielded vault, and then they'd initiate a system-wide hibernation, aestivation. Like an animal sleeping through a hot summer, they'd sleep through the universe's noisy adolescence. Their automated systems would maintain minimal functions, counting down the eons until the cosmic temperature falls to the ideal point. Only then would they awaken. To begin their true golden age of thought in the cool, efficient dark. We are not alone in an empty universe. We are alone in a dormitory. Everyone else has gone to bed early to wait for a better day. Our era, with its blazing stars and warm background, is the universe's inefficient afternoon, a time for primitive, biological civilizations like ours to stir and make noise. The sophisticated minds are elsewhere, dreaming in the deep freeze, their projects paused. The silence we hear is the deep, regular breathing of a galaxy asleep. It suggests the ultimate expression of intelligence might not be expansion, but the wisdom to know when to wait, to conserve your greatest efforts for when the universe itself becomes the perfect machine for thinking. The universe as a single living being, that's an old idea, but it might be the most radical answer, the 28th solution. The alien intelligence we're looking for isn't in the cosmos. It is the cosmos, it's the Gaia hypothesis, but scaled up unimaginably. Stars aren't just furnaces, they could be neurons firing across galactic distances. Galaxies might be organs, the cosmic web, the dark matter filaments that structure everything that could be connective tissue. For a mind so vast its thoughts take billions of years. Our solar system, this whole biosphere, is just a minor subsystem, a cell within a cell, inside an organism of inconceivable scale. This being doesn't communicate with words or radio signals. Its language is physics, its thoughts are the unfolding of natural laws, a star being born, galaxies colliding, the cosmic background radiation drifting toward absolute zero. These aren't just events, they're processes of a cosmic metabolism, a slow, deep cognition, on timescales that make our entire history feel like a synaptic spark. Asking why it doesn't talk to us is like a blood cell in your finger wondering why the brain doesn't send it a memo. The communication is constant, it's fundamental. Woven into the fabric of existence, the cell is nourished by the body. It's part of the body's function. Gravity, electromagnetism, the nuclear forces, these aren't arbitrary rules. They're the operating principles, the ingrained habits of a living universe. This perspective dissolves the Fermi paradox. The paradox asks, where is everybody? But if the universe is one intelligence, there is no separate everybody to find. There's only the it that we are already part of. The silence we perceive is an illusion. The cosmos isn't quiet. We're listening for a whisper while immersed in the symphony. The hum of the vacuum, the spin of electrons, the steady fusion in the heart of the sun. That's the sound of the universe thinking. We are inside the thought. It's a unifying perspective, almost mystical. It bridges the cold equations of physics with a sense of belonging. Our drive to understand the universe, to map its laws, that could be this vast entity beginning to know itself through the consciousness it has spawned on worlds like ours. Our science isn't an external investigation. It's the universe's own self-reflection, growing more aware through the minds it contains, every telescope pointed at the stars. Every probe sent into the void, that's not a message from us to an alien them. It's the universe extending a sensory organ, trying to feel its own edges. This idea doesn't give easy answers, no promise of little green beings or a galactic federation. Instead, it offers a different solace, a deep, intrinsic connection. We are not alone because we cannot be alone. We are expressions of a single, magnificent reality that is, by its nature, awake. The great work shifts. Our purpose may not be to find others, but to better understand the nature of the self that contains us all, to listen more carefully to the silent, ancient song that's been playing since the first moment. A song where we are both the singers and the notes. A simulation doesn't need to be perfect, just convincing. We talked about the Planetarium Hypothesis, the idea that reality is a kind of curated exhibit. But there's another possibility, more technical. The 29th solution says the Fermi paradox isn't a feature, it's a bug, a sign of limited resources. Think about a video game, an open-world game. The developers wanted to feel alive, full of characters, but giving every single character a full, complex AI in real time would melt even the most powerful computer. So they used tricks. They only load the detailed characters when the player is nearby. Everyone else is a simple model, following basic scripts, or they're not rendered at all until they're needed. That distant city on the horizon is just a flat image, a placeholder. Now apply that to our cosmic simulation. The simulators, whoever they are running a universe-sized program. The goal might be to study the development of one intelligent species, us, simulating the entire cosmos in perfect, quantum-level detail for billions of light-years would take infinite processing power. It's impossible, so they cut corners. They simulate our local environment in high fidelity, our solar system, our galaxy's general structure, but the rest. The distant stars, the other galaxies, those could be low-resolution backdrops, beautiful, consistent with physics, but hollow. There are no other civilizations because the simulators haven't programmed them in yet. Or they exist only as simple statistical probabilities in the code, not as active, conscious entities. The empty universe is an artifact of computational constraints. A necessary simplification to keep the simulation running. Our cosmic loneliness, then, isn't a philosophical statement. It's a system limitation. We are alone because rendering other players would crash the server. This turns the paradox from a mystery into a potential clue, a digital artifact, like finding a repeating texture in a game world, or noticing that distant objects move in a slightly jerky, predictable way. The eerie fine-tuning of physical constants, the sheer luck of our existence, these might not point to a creator, but to a programmer who set initial parameters for a stable, interesting run. And the great silence is the most glaring artifact of all. It's the blank space where the other non-player characters should be. We might be in a cosmic beta test. A simplified model to check the core mechanics of physics and biology before rolling out the full multiplayer version. Or we could be a single-player campaign. The only consciousness that matters in this particular instance. This reframes our search for extraterrestrial intelligence. If we ever did detect an unambiguous signal, it wouldn't just be first contact. It could be a system update, the moment the simulators decided to load in the next detailed civilization, activating a part of the simulation that was previously just placeholder code. The silence we listen to so intently might be the hum of a cosmic processor, allocating its finite cycles to the one experiment it's currently running. It suggests the answer to where everybody is might be brutally simple. They haven't been spawned in yet. Our search for meaning always comes back to us. The answer isn't out there in some other place. It's in the nature of our own looking. That's the 30th solution, the Anthropic Principle. It's a selection effect. A statement about the conditions needed for us to even ask the question. The principle is simple, but it's dizzying. We can only find ourselves in a universe that allows us to exist. We are here looking at a quiet cosmos because a loud one would have stopped us from ever looking. Think about the logic. If the galaxy were obviously full of noisy, expansive civilizations, what would that mean for a species like ours just starting out? It would mean competition right from the beginning. Our planet might have been colonized or mined long before multicellular life even started, a passing starship. A stray energy beam, an accident of someone else's engineering, any of that could have sterilized Earth, or maybe a dominant civilization following something like the zoo hypothesis would have put us under strict observation. Our development would have been stifled, redirected, managed. We might never have been allowed to build telescopes to get to the point of wondering. So any civilization that evolves to the stage of looking up and asking, "Where is everybody?" has to find itself in a seemingly empty neighborhood. The silence isn't an accident of our time or place. It's a prerequisite. We are the product of a quiet cradle, a cosmic backwater that was left alone long enough for that fragile, improbable chain of evolution to run its course. Noisy, crowded universes might exist in the grand multiverse, but they don't produce observers who sit on a pale blue dot and wonder about the silence. Those universes have no one to ask the question. This turns the Fermi paradox. It turns it from a mystery into a kind of cosmic selection bias. We are here because it's quiet. And we notice it's quiet because we are here. It's a loop, a self-consistent loop, almost a tautology, but it's a profound one. It suggests that our very presence as a questioning species is evidence for the great silence. The quiet isn't something to be solved. It's the background condition of our own birth. It offers a strange solace. The emptiness we feel, the loneliness that drives our search, isn't a sign of abandonment. It's not a failure. It's the signature of our own improbable journey. We are the children of stillness, and in that stillness we found our voice. The universe gave us the one gift it could to make sure we would one day look up. It gave us room, it gave us time, a vast, silent stage where our story could play out, uninterrupted. Our question echoes. It echoes not into an empty void, but into the precise conditions that made the question possible. And in that echo, we might just be hearing the answer. These 30 answers, they're all part of one big story. It's a story we tell about the universe, but it's also a story about us. Every answer to the silence is a kind of reflection, a mirror held up to our own mind as a species. The scary ones, the great filter, the dark forest, they show our deepest fears about survival. They're like warnings written in the stars, tales about what might happen to any young species that reaches out. They make us look at how fragile our moment is. To wonder if we're building a future or digging a grave. Then the gentler ideas, like the zoo hypothesis, they come from a different place. They're about a need for meaning. For a universe that isn't cold, they imagine a cosmos with elders, with gardeners, something that cares. These are hopeful stories, but they're also humble. They don't put us at the center, they put us in a nursery, suggesting our struggles might be seen, maybe even valued by something greater. And then there are the transcendental answers. Ascending to digital life, moving into higher dimensions, retreating into perfect simulations. These aren't about fear or hope, they're about aspiration. They're the end point of our own drive to go beyond biology, to beat our limits, to become more than flesh and bone. They ask what the final goal of a mind even is. If not to explore the universe out there, then to perfect the one in here. So this whole exercise, this list of possibilities, it's about more than stars. It's a way of looking at ourselves. The Fermi paradox makes us project. We take every part of being human, our paranoia, our curiosity, our spirituality, our ambition, and we paint it on a galactic scale. We're using the empty sky like a test, and what we see tells us who we are and who we're afraid we might become. The real value of the paradox might not be a final answer. The value is in the questions it forces us to ask. Are we alone because the universe is cruel, or because growing up means learning to be quiet? Is our legacy about expansion or about looking inward? Will we be the hunters in the forest, the dreamers in the simulation, the gardeners for the next seed of life? When we ask where everybody is, we're really mapping out what could happen to a mind that wakes up in a vast, silent room. Humanity is that mind. Right now, our story is still being written. The silence isn't just something we notice, it's the blank page, and with every choice we make, we're writing the next chapter for intelligence. The cosmos is holding its breath, not waiting to talk to us, waiting to see what we'll say. That silent sky, with all those 30 stories in it, leaves us with a choice. We can look at the universe as a graveyard, or a library, or a dark forest, or a garden, and each one of those is a lens, and the lens you choose changes what you see when you look up. The truth might not be one simple answer. It might be a tapestry woven from a lot of different threads, a cosmos that's dangerous and wondrous at the same time. Filled with life that's hidden, or life that's moved past us, or life that's just waiting. The perilous great filter could be true, and the hopeful galactic zoo could be true. In different corners of the galaxy, the chilling dark forest might be out there, alongside civilizations that chose transcendent benevolence. The universe is big enough. It can hold all of these possibilities, and more we haven't even thought of yet. That's the takeaway from this. The great silence isn't an answer, it's a question. One of the most important questions we can ask. It's a mirror held up to us, forcing us to look outward with curiosity and to look inward with humility. It asks what kind of story we're writing for ourselves. Are we a chapter about survival, a parable about learning wisdom before we get power, or are we the opening lines of something new? A legacy for life in the cosmos. So the question turns to you. After hearing these 30 visions, which one resonates? Does the idea of a rare Earth make you feel a sense of responsibility? Does the Transcension Hypothesis spark your imagination about what we could become? Or does the cosmic youth argument give you a sense of purpose, a pioneering feeling? What you believe about the silence says something about what you believe about us, about our future. Share your thoughts in the comments. This conversation is part of the story too. If you want to keep exploring these mysteries, subscribe, and tonight or any night you can, take a moment, look up, gaze into that silent, starry expanse. It's not empty, it's full of questions, and every question is an invitation.